right, live from Wonderland, we are architecting Alice. Okay, so I wanted to show for others in my own memory here how I got this working with our WebRTC because I got a friendly email from my internet service provider telling me that I used a 1.2 terabytes of data so within the month of May. So I realized then um, that we were going to Discord and back. So problematic. So basically, the answer, as with most things, is WebRTC. So so you can see that we are not allowed to do get user media within OBS, which is fine by me. Um, but we can, so we can add, and I'll make these profiles uh, obviously public. So desktop. Okay. All right, so I've got another window here. So I'm using this WebRTC-video/room GitHub thing, and they have a .herokuapp.com. And so then we say accept on the other machine, and boom, here I am. And now we are not. I mean, I can tell. I mean, look how much faster this is. This is insane. So it's great. Now we do have the little whatchamajingies here in the bottom, but I think we can fork this project if we wanted to. So the most important part though is that you got to do the Alt Tab to do the get user media, and you know this seems like a little bit. Let's be honest, that seems a little bit hacky. So may or may not be around for us in the future, but for now this is a mechanism we can use. All right, let's get to it. So what are we doing today? Same thing we were doing yesterday. So because we were not done. I tried many a WebRTC thing. What the hell? Why are there so many? Okay, so main point of recent discovery was okay. Let's just work through this. Okay, so we're in the middle of very many things right now, and we're way deep in the stack. But so I'm not going to do an overview of where we're at. Um, Suffice it to say, okay, no, I am going to do an overview of where we're at. Okay, so where are we? Rename window. Say. So we're teaching Alice how to say hello. Why are we teaching Alice how to say hello? Well, I think it's plenty covered in the last video. Basically, this is our basic case for PR response. Pull request response for static analysis. So we talked about time windows and yada yada. Basically, this is our simple case. So, the reason why we're doing this is because we're playing with the system context. We're trying to understand what is the system context. How does it relate to input objects? How does it relate to the other objects within our current code base? And how do we effectively maintain our chains of system context via their links? But oops, we had this realization that the links are effectively really we need to rename parents to links because it's not really parents, it's links, and maybe they're parents, maybe they're not. It's really just something they're associated with. It's basically we're turning this into a pure DID. Um, and so yeah. Okay. And we're trying to make callables out of these things. So we had some handy dandy code that was over here, which basically we could wrap a generator, or we could wrap a coroutine, we could wrap an async function, or whatever. We can wrap basically we had this wrapper code that's like, we can wrap whatever, right? Okay, well now we don't necessarily have a specific thing. We have this data flow, aka the system context, and within that system context, we may want to use it a variety of different ways, right? So some things. So for example, the main, what do we really care about? We care about like so thinking about this as communicating with Alice as the core of it sort of simplifies the problem space, right? So we care about communicating with Alice, right? If we can communicate with Alice, if we can communicate, with the machine in this shared language, we can do anything. right? This is the hypothesis. So to that effect, um, we're going to iterate over her thoughts. So, and so this is basically the same as Wonderland. Wonderland async init, or maybe just Wonderland async, right? So, so we can say from Wonderland import Alice, right? And there she is. So what is Alice in this case? Well, Alice is the system context, right? So what is happening in Wonderland? Well, Wonderland is going through and loading all of the, let's see, so Wonderland is just going to be an alias for system context. So we can say from Wonderland import Alice. So so in this case, it would be forethought in Alice, right? So then, we already have code that handles transparently the run when you're in a nested async IO. We've got all the code for that right now. I think there is a feature branch somewhere which attempts to, where is it? Util Python within method. So this is just, I mean, well, you can see it. So there's some bugs basically, and so we are um, so for some reason, I don't know if there's some bugs. Maybe there's not even some bugs. I'm not sure what's going on here. Suffice it to say, if we don't do this, the kernels blow up when we run them in testbook for some reason, I think, or maybe it's within the actual notebook. I think no, it's within the testbook. Yeah. So basically, we check once if when some versions of IPython. Okay, why are we talking about this? Okay. The point is we can run async code with a for loop as if it's not a async code. So not a big deal. We'll just stop talking about that. Okay, so and then you'd have, also from wonderland.async import Alice, which would allow you to do your async forethought in Alice, right? Okay, so all right, so let's play with this async with Alice, async forethought in Alice, async with Alice, async with Alice as Alice. I like that. I like that. Yeah, I like that. That's nice, right? So there we got a class. Um, so this looks a little more. This looks a little more reasonable here. So basically, async with Alice as Alice, async for thought in Alice. Okay, so async with Alice as Alice, async for thought in Alice. Okay, okay. Wonderful. Yeah, so perhaps we should support the following, right? So perhaps we support Alice system context, async with Alice as Alice context, async for thought in Alice context. Thoughts. And this is also, okay. So, and what happened here? Um, so we are playing, remember, we're trying to figure out what is the most ergonomic API, right? What is the most natural feeling? What is the most natural mode of communication with Alice, right? And to that effect, we're experimenting with this, um, we're experimenting with what it's like to write code that talks to Alice. Okay, so asynchronous system context, asynchronous CTX, async for thoughts. So this says basically thoughts is AKA, so okay, so basically dot thoughts is the default, which means the call will do the default, but if we wanted to be explicit, right, because we're in this block from 334 through 337 playing with the explicit API. So and we'll just put this after, right? So then now 334 through 336 is playing with the explicit API. 337 experiments with the fact that the thoughts is going to be aliased as the default. And then 339 and 340 async with Alice is Alice and async for our thought in Alice. We play with a even more abstract API where we're doing a single context entry, and therefore if we have a context on Alice. And on 342 and 343, we're playing with a non-async version of an iterator, where on the initial iteration we will start Alice's background thread, right, and basically just go immediately into uh, the first iteration of the loop that we might see after 337 or after 336, right? The body of what would be the loop for 336. So, forethought analysis. Hmm. So when we kick this thing off, when we kick this thing off, we can do if the default if the deep if the default takes no inputs, we can iterate as we please with 342. Um, forethought, forethought analysis. Okay, forethought analysis. Forethought in Alice. Forethought in Alice. Forethought in Alice. Forethought in Alice. So how could we make it so that we can interact with one instance of Alice within that for loop? Or maybe we don't want to interact with one instance of Alice within that for loop. Maybe if we call that for loop, we're expecting that we're interacting with a global instance of Alice. A lot of people like globals. Um, okay, forethought and Alice, print thought. Okay, okay. So let's play with another example. This is very generic, not concrete enough. So finish after social work on entities and also this conversation, which is somewhere else in the screen. Um, hmm. So, what else? Async import else. Okay. From thought in or for thought in Alice, print thought. Okay. I think I think that okay. Here we go. Alice equals Alice. Forethought in Alice. Okay, so this is better because there's it's not just pulling from the global scope. Um, however, okay, uh, forethought in Alice. Yeah, okay. From Wonderland import Alice. I think we can do this. So if we directly import Alice lowercase from Wonderland, we can just instantiate. We can do what we're doing on 345 within the body of the loop, or effectively, whatever. Basically, when we do the first iteration, we'll start here, and we will create the new instance effectively. So let's go see what Python has to say about writing loops. Or iterator. Iterable types. Okay. Oh my God, this is so much easier than I was making it. Wow, look at this. Okay, look how easy this is. So all we have to do is say, okay, wait, I swear it was gonna be easy. What are we gonna do? Oh yeah, we don't need to do this because we can say, okay, so def Alice, right? So we'll basically dynamically populate this. And we'll say, so this will be like, coming from this sctx.deployment Python, we'll have sctx deployment Python, sctx deployment Python. So let's support the case of this first. Okay. Okay, so we'll say as iterable. Make as iterable. Okay. Make correct Python callable. Right. So we say sctx. Okay. All right, here's a function. All right, so to do if uh, deployment has operations for uh, has non-auto start uh, inputs or non-auto start operations with, okay, so we know it has a Python deployment, right? Which means we know we have a function that we can call effectively. Um, okay, I'll be right back. So we got to figure out, okay, now we got to figure out, okay, how do we make it? We're going to grab this wrap code now and we're going to start writing something like this. I don't know. We'll figure it out.